Alright, we went ahead and took one of our old style, general style mag base, and it's got a little adjustment here. We can set that where we want, and we're running around here. We're going 50 there. We're gonna have to get a mirror so we can read under here, and also what we got upside down here, and it's plus 70 to minus 15. So actually if we go here now, it'll probably be plus plus 93. Alright, so we got to come up on our lower unit right here. And we got to come down. No, we do have to come up. Okay, there's 50 thousandths there. Let's reset the indicator at 0. Alright, here we come up. 20 and then 0. Alright, this 20 right here. We should be able to jack it this way. Alright, there's 0. 0. Minus 15. Alright, we're zeroing it out. Let's zero it out right there. 0 plus 15. There's 10. There's 15. Zero. 10. 0. Minus 90. Or minus 10, excuse me. Okay, 0 minus 5 plus 5 plus 10. Five, 5 minus 5 0. Okay, we're within 5 thousandths on this end. Let's go put it on the other side. Ain't not bad. Alright, 0. Pretty close to 0. But we line up almost 70 to the side. Okay, there's 35. That should be pretty close to is minus 25. Minus 25. That's like 50. Getting pretty close. All right. 0 minus 9 minus 5 plus 5. Okay, there's 0. Minus 5 minus 5 minus 2 and 0. Alright, now let's put it back on that side one more time. Wish I actually had one to sit on both sides at the same time. And anyhow. Alright, 0 minus 20. 0 plus 15 okay, so what we got to do is we got to go ahead and we got to let it go that way. Alright, so we got 90. Now we'll bring that back to 0 plus 5 plus 9 2 and we're 2 there, and we just need to keep going. There, it's like 2 and 2. And there's 2. 2. 2. All right, that's pretty good. That's fluctuating about 1/1000 there. All right, back to our other side. Zero plus 8. 0 casting my own shadow. Minus 8. Minus 8 and plus 8. Okay, so let's go over here where we can look right down on it. And all we're doing is shifting it right across the side here. And we need to make it go minus here. Zero. About 1. Minus 1. There's 0. Plus or minus a half. There's 0. Alright. Both sides are within 1/1000s right now, running parallel with the bar and the OD. So now our bearing caps, actually let me move you back here. Alright, our bearing caps now should slide on. And we got our grease zerks open. Alright. Okay, our set screws we're going to find our set screws. With 3 of them equally spaced, and just kind of tensioning them the same way. And this length of this bore is so straight. All we want to do is create enough pressure, not to crush them, not to hold them, not to distort them, just to secure them in place so we can take vibration out of the bar as we're operating here. If it's only enough to just create enough drag so that you don't vibrate the bar, that's all you need to do for bushings. Alright, now we can go ahead, and I think we're ready to spin the bar now. And I'm going to go ahead and put in some oil. It is distributing oil. You know, you can see it going down through there. Alright, we're bringing it all the way here because we're going to check our travel now. Alright, I got you. You can see that the insert in the tool bit can be accessed, and when we rotate this around, we'll be able to tighten the set screws, and then we'll be able to jack it with the dial indicator against the point and adjust the feed, and then do the final tensioning on there. Alright, so anyhow, we're going to check our travel. We know that we're right there. Alright, so I'm going to go ahead and rotate this again. Alright, now I'm going to move my carriage all the way to the other end, and we're going to see that opening go past the other end of the bar. Hopefully. There we have it. That's our max travel. We've made it. We are set up, ready to put the bit in there and bore this tube. Alright, we've accomplished our goal for this evening, and that was get this ready to bore and, you know, have it mounted in here. We pulled our first day down at the duck boats, and I think we got off there about 3 or so, and we headed on home, and so we were able to put in another 4 hours here. And of course we stopped for dinner, and we got out here and we finished up those bearing supports, which really worked good. I'm happy with actually how everything slid together. I mean, you know, it's not too hard to go ahead and dial this thing in, and of course every time you dial here to get here, you're going to affect over there, so you got to go back and forth. But you saw it go together. We're good. Now, I've got 3 choices of boring bits, and tomorrow afternoon, after we get back from the duck boats again, I'm going to take one of these 3 style bits, and we're going to go in there and I'm going to grind a chip breaker into them, because ideally when you bore this thing, the ideal chip would probably be about a 1-inch little curl and then break. Little 1-inch curl and break. And you get a lot of little chips inside this drum is going to be a lot better than if we create a real long stringy one. Because stringy chips and boring bars, you know, it it can be a hassle. It can wad up, it can knot up, it does all different kinds of things. It's pretty smooth in here, and they don't really have anywhere to go, and you might get away with going from one end to the other end and have a spiral chip in there. The chances are slight that it would be a good bore. So anyway, we're gonna go ahead and attempt actually putting the chip breaker in here and see if we can actually get a chip to break. And then we're going to talk a little bit about how much we're actually taking out of this diameter. We got to make it fit over that shaft, and we think that there's about a 1/16 of an inch of interference, I think is what we checked the other day. And then we're going to want to give it a little bit more than that, and we're just kind of throwing a number in there because we're going to have a weld seam running down both sides of this thing, and I know it's going to egg shape the pipe. It has to. How much? That's only a guess. So we're trying to, that's kind of what we're up against on this job. So we'll find out tomorrow. Alright, we're going to go ahead and pop this cap loose here because we're going to be able to play with our bit. We got to get some insert or set screws to tighten our tool bit. Now this is just a little bit under 2 7/8, and we got the shaft it's going over is 2 15/16, 1/16 of an inch bigger, which is about 32 thousandths per side. And we need to give it clearance over that shaft because there's going to be 2 weld beads going down here, and we know that it's going to egg shape it. So we're still kind of playing around with how much over we want to give it, and I'm almost thinking somewhere around 20 to 30 thousandths should give it plenty of clearance there. We're going to go ahead in the other room right now, and we have 3 bits, either straight if you're going to come into a shoulder. Now these are TSA, TSE, and TSC. Different angle of approach. A straight, a 45, and one a little bit less, about 30 degree there. And this is the one that we're going to choose. Now all of them are set up so that when you broach your key or your hole in the center of your bar, they're already set, offset, and tilted forward to be in the right geometry to cut at the contact tip here. Alright, and what we want though is we don't want a long stringy chip in here, so we're going to make an attempt to put a chip breaker in here, which is a groove right parallel to this leading edge right here, and so that the chip will come in, curl, and then curl and break, curl, break, curl, break. Sometimes they flake, depending on the material you got and the speed and the feed you're going. Those are also other variables in breaking the chip, but putting a chip breaker in is your first step. Alright, so let's go in the other room on the diamond grinder, and I'm going to quickly show you how I'm going to attempt to put that chip breaker in there. Alright, we're going to fire up the grinder here. This is a diamond wheel here, and I'm going to use the very edge of the corner of this wheel. Of course, this is just a real thin layer of diamond material on this here. You want to treat this very gingerly, and you know, just like some grinders and people that own the grinders, or the company that owns the grinders, doesn't want you to grind on the side of the wheel. And that's the same thing somewhat on the diamond stones. A machinist is going to be very particular. If you take your tungsten and you're sharpening your tungsten on here and create a groove in the center there, you're gonna get them irate. I've seen them get irate before. Anyway, I'm gingerly going to go ahead and put that chip breaker right along that edge right there. And here we go. Okay, I'm just working a parallel straight line And I'm looking at the distance between the edge and the edge of the curl, and also the depth of that curl. Alright, this is a small bit, so it doesn't have to be extreme. I gotta get it on the right light here. And then you can see from the end. Let me see if I can get a little better here on the light. Zoom back out here so you can see. I just want to kiss it on the face here, because I want to really see how much of that flat I got there. You want a little bit of flat there because that's going to be the strength or the longevity of your tool bit. If you have that razor sharp, it can go more quickly than if you have a tiny flat right there. The chip breaker will still work, and it's a slight slope and then a real sharp edge, so it's forcing it to run down the ramp and then turn real fast. That creates the break. Alright, now while I'm here, I'm just going to go ahead and I'm going to grind a little bit off of here and here on the high speed grinder over here, and then I'll be right back. All I did was hit a little bit down in here so that I wouldn't be dragging. You don't want to drag the steel on your diamond wheel. You want to try to keep the carbide grinding on your diamond and the high speed, or the steel grinding on your high speed grinders. And I'm just giving I want to just make sure it's a little radius on there, not real razor sharp. I got to get a little bit more clearance there. Alright, now we're good. Flat. Little water. Alright, I think we got a good starting bit here. Let me wipe this off. Alright, I can shut that off also. Slight little flat right on the top here. Nice clean on this surface right here. Slight little radius on the nose. And you can see the slope down and then a sharp backside, and that's going to force the chip to break. Let's go try it out. Alright, we got the tool bit slid in here, and we can reach in. We're going to reach in with this one here to lightly push it against the inside wall, and we have a ball end mill, Allen head here, so that we can go ahead and tighten it slightly when we touch the wall, so we can set the height at 0. Alright, so we're bringing it in just to where we can reach in here. Just bring it out there to where it touches that side, and then with the ball end mill, which lets you reach in at an angle, and go ahead and give that a little tension. Now we're going to back up here, and she is tight. What we're going to do now, we're going to go ahead and set our dial indicator straight against the point here, like that. Pretty close to being true. I'm not going to worry about being exactly lined up. Now our adjustment here, we will set this at 0 here. We're going to rotate this bar down here so you can see the dial itself before I do this. Alright, maybe a little zoom out there just so it. Sometimes I take those little locks right off of the dial. I hardly ever set my dial right at there. Alright. Now, we just basically touched off inside here, so we're gonna be playing around with the amount taking, seeing if we're creating a chip, how it's gonna handle going through, playing with speeds and feeds. So we don't want to go for our final dimension right off the bat. We want to go ahead and we're going to ease into it, and adjustment nuts got to come up to the butt end of the bit here first. Alright, there it's tight. Now we may have had a little excess on here. We're going to loosen it slightly so we're not forcing too much, and we're going to take 10 thousandths per side. Alright, lightly snug both of our set screws here, holding the boring bit. Alright, I think that's good for a start. Find out where we're at. Alright, we're going to bring this in here a little bit so we know we're close. So we can set 0 on a travel, just to have a place of reference. And see, we'll go ahead. We're going to put the tip exactly even with the edge of the bar here. And that is 0. But we're going to come back just a little bit from that. Alright. Now we're going to slide our bearing cap on. And we're going to lightly snug those. And give ourselves some light here. Alright, RPM, we're going to go ahead and we're going to try. That's about 131 RPMs. About 300 surface feet a minute at 3-inch diameter, I believe. Maybe I'm rattling off here a little bit. Just so there's no BS in here. Okay, this is our scenario for our first attempt here. And so anyway, the inside diameter to start is 2 inches 875. Now we want to multiply that by pi times the RPM 133 divided by 12 equals 100.10 surface feet a minute. And that's a good spot to start. You know, we're not slow and steady and a good cut. I mean, we're going to be watching the chip. Alright, now I'm going to pick a feed rate to go ahead and buzz through this thing. And I think I'm going to go ahead and I'm going to give it an attempt at about 8 thousandths per revolution there. It's a pretty swift cut to pass on. And I'm really hoping that we can get some nice action. Alright, so I think we can get some good action. Let's see what we got here. Let's get her spinning up and get some oil on it. Pretty good tolerance on the bearings for the oil not to really just like run through it. Once it starts siphoning, it does pick up on it pretty good. Let's check our feed direction. And we're feeding. Let me get you in close to see that start off. Alright. I know where to hold the light though. And I'm going to shine it down here so we can actually see the cut. Watch the first chips. Here. They are breaking. It's looking pretty good in there. Sounding really smooth. They're flaking out about 3/4 to 5/8 of an inch long, and then they're breaking. There's a little bit longer one, but it's still breaking. Starting to get just a little stringy there.